prediction of charge or charge density by electric flux. So in these problems, I'm using the concept of electric flux to find the charge and the charge density, right? So in first case, what I have done, I am taking here a cube of edge length A, and the electric field is variable here, that is E is equal to A x square, it is I, so means it is dependent on the x coordinate. The cube has one edge on the x-axis, and the corner of the cube is at a distance of A from the origin, right? So that means the electric field at this point and at this point will be different. Now the area of the surface of the cube through which the electric field is passing is given by A is equal to A square, then it is I cap, right? So the flux passing through the cube at this side, that is the inward flux, is phi in is equal to EA, means the electric field at the distance of A dot A vector. So it is coming out to be A cube, then it is A square, so it is A raised to power 5, right? Now let's come to this face. So this face is at a distance of 2A, so means our x is now equal to 2A. So phi out is equal to E2A, means electric field at this distance dot A vector. So it is equal 4A cube, then it is A square. So then it is equal 4A raised to power 5. So this is 4A raised to power 5, right? Now the flux, total flux, that is outward flux minus inward flux in the cube, is given to be phi is equal to phi out minus phi in, that is 4A raised to power 5 minus A raised to power 5, that is the phi in. So that comes out to be 3A raised to power 5. But we know from the Gauss's law, phi is equal to charge enclosed divided by epsilon naught. So that is equal to 3A raised to power 5, right? So this implies then Q is equal to 3 times epsilon naught A raised to power 5. So this will be the charge enclosed in the cube due to the electric flux inside the cube, right? Now let's come to the second part. We have to find the charge density. So for this, I have taken here a case at a distance of say R from this origin. Suppose the electric field is given to be KQ divided by RQ, means electric field is function of the radius or the function of the distance, right? Now I can imagine here at a distance of R a sphere, that is a Gaussian surface, and I take this spherical shell of radius r and thickness dr, and I will see what is the flux coming out through this, and then I can calculate what is the charge. But I am making it simple to use this concept. So instead of taking the whole sphere, I am taking a part of the sphere that is in the shape of a cuboid whose thickness is equal to dr at a distance of r, right? So now phi total, that is the flux in this surface, in this region of the surface of the sphere, is phi out minus phi in. So phi out is here and phi in, it is here, right? Now what is phi out? Suppose the surface area of this surface is equal to S. So this is S here. So surface area of this surface is S. Instead of taking the surface area of the whole sphere, that is 4 pi r square, so I am taking here it is only S, right? Now phi out is given to be, it is K Q, then it is S. So this is the surface area of this, then divided by R plus it is dr. So this is R plus dr. So it is KQ, because electric field at this point will be KQ, then it is R plus dr, then raised to power 3, so it is S, where S is the surface area of this surface, then minus it is KQ, so it is KQ divided by R cube, then it is S. So now we have to find the charge density as a function of R. Suppose rho is the charge density, then charge enclosed in this small region is equal, it is rho, then it is S, the surface area of this surface, and then thickness, so it is dr, so it is volume charge density, then it is volume, then it is charge enclosure divided by epsilon naught, right? Okay, now doing a little bit of mathematics, so kq divided by r cube we take out, so what we are left with here is 1 by 1 plus dr divided by r raised to power 3 minus 1, then it is rho equal to rho, then it is dr divided by epsilon naught, because s will cancel throughout, right? Now using the binomial theorem and using the linear approximation, what we get, k cube divided by r cube is 1 minus 3 dr divided by r minus 1. So 1 and 1 cancels. This is equal to rho dr divided by epsilon naught, right? So now we are left with minus 3kq divided by, this is r cube, then this r, so it is r raised to power 4, then it is dr, so that is equal to rho dr divided by epsilon naught, right? Now dr will cancel, so what we get, rho is equal to minus 3kq, then it is epsilon naught divided by r raised to power 4. So this is the charge density here because of this electric field, right? So we can also write it as the rho as a function of r is given to be, it is minus 3, it is kq, then divided by r raised to power 4, so it is epsilon naught. This is the charge density as a function of r from the point O due to electric field kq divided by r cube.